welcome to the Deep Dive. Today, we're not really talking about communication as just, a soft skill, something nice to have.
No, not at all.
Our mission here is to frame it, maybe reframe it, as a hard, essential engineering control, absolutely critical if we want to succeed in building these next-gen hyperscale data centers.
That framing is spot on. We're building what are essentially utility-scale industrial facilities now, and the demands from AI, they're pushing us towards, well, zero margin for error.
Zero margin?
Yeah. If you look at where the big capital risk lies today, the vulnerability isn't really the physical kit anymore. It's the human interface. It's the procedural chaos that can just creep into these incredibly complex systems.
Let's make that real right now. Let's talk about a tale of two timelines. This is drawn straight from the commissioning floor. So imagine a critical UPS commissioning window. That's the uninterruptible power supply, the absolute backbone power backup.
Crucial piece of equipment.
Okay, timeline A. A technician is working through the steps, got the printed method of procedure, the MOP, right there. But last week someone sent an email, undocumented, temporary directive about a critical breaker setting.
Happens all the time.
Right. The technician misses it or maybe disregards it because it's not in the MOP. Proceeds based on the printed document, energizes the system, and the result.
Catastrophe. A system trip, multi-million-dollar loss could be months of delay. And a serious safety threat. All because of that one undocumented change.
Okay, now let's rewind. Timeline B, same technician, same MOP, reaches step 4.7. But this time, the procedure, the culture, includes a verification hold point.
Ah, okay. So it forces a pause.
Exactly. Instead of just flipping the switch, the technician stops. He uses precise required language. Over the radio, maybe in the project log, Data Hall 4 at a verification hold on MOP UPS 7B step 4.7. Settings match the one line.
Good start.
Then adds the crucial part. Requesting positive confirmation that no temporary directives exist prior to energization.
That phrase, that's the key. It acts like a safety interlock.
It is the safety interlock. It forces that pause, triggers a formal check. Someone says, hang on, what about that email?
Right, so the email gets flagged.
It gets flagged. A formal red line is issued for the MOP. It gets reapproved through the proper channels, and then the team proceeds. Safely, zero incident.
That's the difference. That's moving from chaos to control.
And our whole mission today, really, is to give you the exact protocol framework you need to shift every project, every single critical step from that disastrous timeline A to the successful controlled timeline B.
And the urgency for this, it's immense. You look at AI, it's driving this radical shift in infrastructure. Our sources are pointing to, 55% jumps in energy efficiency needs?
55%, yeah.
And a staggering 54% need for higher power density, packing more power into smaller footprints. We are building incredibly complex mechanical and electrical powerhouses now.
These aren't just big buildings anymore.
Not at all. And when downtime hits these places, the root cause, it almost always traces back to the power and cooling infrastructure. And critically, how humans interact with it.
Which means that quick text message or that, vague email that might have been okay on a traditional construction site.
It's fundamentally dangerous in this new environment. It's not just introducing risk, it introduces predictable, systemic costs.
Okay, let's hit the data then. Prove the financial urgency here. Globally, poor communication. It's like this multi-trillion-dollar anchor on business. For U.S. businesses alone, the estimate is around $1.2 trillion annually.
It's a staggering number, almost unbelievable. The elephant in the room, as you said.
Right, and we tend to ignore it.
In construction, though, the cost is surgical. You can see it directly. Rework. It's the silent killer of profitability.
How much are we talking?
It costs the U.S. construction industry, get this, $31.3 billion every single year.
Billion, with a B.
Yeah. And here's the really brutal part. Studies consistently show somewhere between 48% and 52% of all that rework directly caused by poor communication and inaccurate data.
Yeah.
Half
of billions of dollars wasted because we couldn't communicate clearly. It's mind-boggling.
Yeah.
But it's not just about the money, is it? The margin compression.
No, not at all.
We're talking about a direct threat to the core safety culture. That chaos, the rush that often comes with rework, trying to fix something that went wrong because of ambiguity.
It creates unsafe conditions.
Exactly. It's linked to up to 39% of all site accidents. So if the commitment is truly nobody gets hurt, then our communication discipline has to be a primary safety tool.
Absolutely. And you can't ignore just plain human error either. Causes about 24% of all data center downtime events, each one costing, on average, nearly $300,000.
Okay, so the cost is crystal clear. Financial, safety. Why isn't this just standard practice everywhere? Why don't organizations enforce this level of clarity?
That's the friction point, isn't it? It sounds almost too simple. Just stop and read the procedure. Just make the call.
Yeah, how do you convince a superintendent or maybe a contractor who's under immense pressure, tight timeline, that pausing for 5 minutes to redline an undocumented change, how do you convince them that's actually faster, cheaper?
Because that 5-minute pause saves you $5 million and 5 weeks of schedule recovery down the line. That's the argument.
Yeah.
And that really brings us to the core idea, the central thesis today.
Which is?
Communication must be treated as a technical control, not a soft skill, not a procedural nicety. Think about it. Our hyperscale systems demand clean, reliable data inputs to function.
Sure, garbage in, garbage out.
Precisely. Communication is the input valve for human action in these systems. It needs its own spec sheet. It needs quality control, just like a physical piece of gear.
So you're saying the framework, the actual way we transmit information has to be just as robust, just as traceable, just as validated as, the switchgear we're installing.
Exactly that.
All right.
We have to elevate the communication framework itself to be a primary safety function. Think about a mandatory readback. That 5-second interaction, treat it like a critical safety interlock. Just as mandatory, just as non-negotiable as a physical lockout-tagout device. It's that important. This isn't about adding bureaucracy. It's a strategic investment that buys certainty. It minimizes operational, financial, and safety risk across the whole project lifecycle.
Okay, that makes sense. Let's get practical then. How do we actually implement this? You mentioned borrowing from high reliability organizations, HROs, like nuclear aviation.
That's right. Decades of learning there. Our sources distill this down into 4 core disciplines, absolutely essential for these mission-critical environments.
All right, let's break them down. Discipline 1.
The MOP as the single source of truth. Simple concept, hard execution. If you are operating or maintaining a critical system, the method of procedure is the governing document, period.
And if something needs to change, that rogue email, the verbal instruction on the floor.
The protocol has to be mandatory, culturally ingrained, non-negotiable. You stop, you redline the procedure formally, you get it reapproved through the established process, and only then do you proceed. Stop, redline, reapprove, proceed. It's the ironclad defense against procedural drift, against timeline A.
Okay, solid foundation. Discipline 2.
Structured messaging. We have to kill the vague narrative updates that just breed confusion and lead to rework. We need tools for clarity, for quick, actionable updates, field reports. Use BLUF.
BLUF.
Bottom line up front. Get straight to the point. So a weak message sounds like, hey, boss, the cooling unit is kind of acting up. We're sort of falling behind on our pre-commissioning checks. Useless right now.
It tells me nothing actionable.
Exactly. The strong, structured BLUF messages, BLUF, pre-test procedure for CRH-12, that's a computer room air handler, key cooling unit, stop due to failed actuator, need mechanical contractor on-site immediately. Impact, approximately 2 hours behind schedule on this activity.
Okay, clear. Situation, action needed, impact. Cuts through the noise.
Instantly actionable. And then for more formal problems, escalations, detailed issue logs, we shift to SBAR.
SBR. Situation, background, assessment, recommendation.
Right. We've all seen those endless email chains, haven't we? Where the actual problem is buried 3 paragraphs deep.
Oh, yeah. Angle.
SBAR forces the sender to structure their thoughts logically for the receiver. Situation, what's happening now? Background, what led up to this? Assessment, what do I think the issue is? Recommendation, what should we do about it?
Makes sense. Forces clarity.
And underpinning both BLUF and SBAR, all communication must use clear language. Specific, measurable, contextual, actionable, and realistic. Define your terms. Don't say improve speed. Say reduce checkout time to 90 seconds. Vague optimism is dangerous.
Got it. Specificity is key. Okay, discipline 3.
Closed-loop readbacks. This is that mandatory 5-second safety check we talk about. You use it for any critical command that changes the system state. Energize, de-energize, open a valve, close a breaker, anything potentially hazardous or system impacting.
And this simple back and forth, it really prevents major failures. Seems almost too basic.
It is the ultimate human error barrier in critical moments. It's mandatory in aviation and nuclear for a reason. The 3-part sequence must be enforced culturally. Sender states the command clearly. Close breaker A4.
Okay.
Receiver repeats it back, word for word. Closing breaker A4.
Got it.
Sender confirms accuracy. Correct. Or if the readback was wrong, they say negative. Stop the action, clarify, and restart the sequence. It eliminates assumption and confirms understanding before action is taken. It's a mandatory check, not optional.
Okay, powerful. And the final one, discipline 4.
Precise and final documentation. We have to treat every written channel, project logs, daily reports, comments, and software as the official auditable record. You have to log your work as if a future root cause analysis or, frankly, someone's life depends on it. Because it might.
So no more finished wiring today.
Absolutely not. It needs to be factual, objective, specific. Like terminated control power circuits 3, 5, and 7 per drawing EL 405, revision C between 14.000 and 15.3 way. That level of detail, traceable, verifiable.
Right. Creates that permanent record.
Now, the key thing is, these 4 disciplines, they're useless if they just live in a training binder collecting dust on a shelf somewhere.
Right. They have to be alive, used every day.
Exactly. The real competitive advantage, the real risk reduction, comes when you integrate these protocols seamlessly into the project's digital workflows. Make them part of the system.
So the technology becomes the enforcement mechanism. It transforms good intentions into traceable accountability. How does that work practically, say, with comprehensive construction management platforms like Innate?
Perfect example.
Yeah.
Those platforms can make these disciplines mandatory checkpoints. Take Discipline 1, the MOP, as the single source of truth. Using a robust digital document management system like Innate Document ensures that random emailed directive, it's not actionable. Not until it's formally logged as a revision request, goes through the digital approval workflow, and is reissued as a new, controlled version of the MOP.
I see. So the system itself prevents acting on rogue instructions.
Yeah.
It builds that institutional defense, creates the audit trail.
Precisely. And Discipline 4, that precise field documentation, it comes alive when the field teams use digital tools, maybe like an 8 plan in progress.
How so?
The technician isn't just scribbling notes, they're capturing exact details. Photos of the installed component, verified quantities like 3 out of 5 circuits terminated, linking it directly to the specific task in the schedule, time-stamped.
Creating that rich, verifiable data right from the source.
Exactly, which then flows directly into the control systems, like Innate Control. Remember that SBAR message about the CRH delay? If that's logged digitally in the field using the SBAR format, the project manager doesn't have to wait for the evening status meeting. They see the potential impact of that delay reflected on their project financial forecast and schedule dashboard, almost in real time.
Wow. So it directly connects that specific technician's structured communication, that field reality, right up to the project's overall health and certainty.
That's the power of digital integration. It makes the disciplines real, traceable, and effective at scale.
Okay, so pulling this all together, thinking about the future of building these massive data centers, the strategic imperative seems absolutely clear, doesn't it?
It really does.
The cost of ambiguity, of sticking with old communication habits. It's just orders of magnitude higher than the investment needed to achieve absolute clarity.
Absolutely. And mastering these disciplines right now isn't just about optimizing current projects, it's necessary preparation for what's coming next. Computational density is only increasing. We're facing incredibly complex, unforgiving cooling systems. Think 2-phase immersion cooling.
Zero room for error in those environments.
None. Error tolerance completely disappears. But the really transformative frontier, and the reason we need this nuclear-grade discipline now, is the very real potential for co-locating small modular reactors, SMRs, on-site, actually powering these facilities directly.
Right, the ultimate mission-critical environment.
That's the ultimate imperative. If we adopt and master something like the closed-loop readback protocol today for closing a simple UPS breaker, we're proactively building the cultural muscle, the operational rigor needed to manage the critical controls of a future nuclear environment on that same site.
So, failing to enforce 3-way communication on a standard breaker today means we have zero chance of safely managing SMR controls tomorrow.
You simply won't be able to compete, let alone excel, in that future high-stakes arena without this discipline baked into your DNA now.
So the ultimate competitive advantage in this whole digital infrastructure revolution, maybe it isn't just the tech, the concrete, the steel. Maybe it's the disciplined shared certainty you create through absolute clarity and communication.
I believe that's fundamentally true. Certainty is the product.
So a final thought for everyone listening. Your action item is simple, but not easy. Start today. Take your most important current objective, the most critical procedure you're working on. Find the vague words, the assumptions, the phrases that seem clear but might not be. Define them precisely. Eliminate the ambiguity now, before it forces you down the path of timeline A.